Okay, to start, the question asks you to consider a car traveling at constant velocity, and it actually graphs this. So this is the graph of time, t, it's written a little bigger here, versus velocity, v of t. For you guys, what color is this? Purple? Lilac? And the graph is a constant horizontal. So the question asks, how far will the car travel in the first 10 hours? So it says from algebra, we know that if velocity is constant and positive, that distance is equal to rate times time. From a little bit more advanced, you guys moving throughout your unit calculations, you know you don't really need to memorize formulas so much as you need to make sure your units work out with whatever you're multiplying. And here's a unit example. I'm going to write this down more in things. Distance, rate in 40 miles per hour, or 1 hour, if I can write the 1 right, times 10 hours. Hours cancels, and we get 400 miles. So that's algebra, and I'm going to draw a little bar here to separate the algebra from the calculus. Yesterday, you learned that distance traveled is the absolute value of the integral of the first derivative of distance, and the first derivative of distance position is velocity. So the distance traveled in our example should be, I'm going to write this out by hand because it's more fun that way, the integral, I want the first 10 hours, is it hours? Yeah, first 10 hours, 0 to 10, the integral of the velocity function, velocity v of t, dt. What is the velocity function again? In this example, velocity is equal to, yeah, it's a constant. So 40 dt, which is equal to 40t evaluated from 0 to 10, or the same 400. And if I'm integrating miles per hour, what I'm getting at is miles. That is a little bit more of an analysis of this. And what I kind of want you to see with something like this is that what I just found was the area under the curve between 0 and 10. I found this area. The area under the curve represents the accumulation of position across 10 hours. Its units should match. 10 hours, 40 miles per hour. And if I take the length of that rectangle times the width of that rectangle, I get the same thing that I would right here. You see how this is kind of nicely working out? The height of the rectangle is in miles per hour, the width is in hours, and if I multiply them, those boxes represent 40 miles. Now, another little unit thing that happens here, and this kind of dissects it, but I think I'm going to switch back to and also do a handwriting here. This symbol, the integral from a to b and dt, are linked. They're not a separate symbol, they're actually one and together. Whenever you go to your calculator and type an integral symbol in, a d follows that. You have to put what your variable is. The variable here, whatever a's and b's are, should match the variable here, whatever your d variable is. But the units are kind of what matters here. So what I'm kind of getting at is that if change in time, is in hours, and these are also hours, and v of t is in miles per hour, then when I multiply hours by miles per hour, we get miles. and the units of my integral are miles. You guys all remember taking derivatives, which changes a unit into a rate of change. This is going the other way. It's taking a rate of change and changing it back to its numerator. So this is valuable because right here, the integral of velocity is total miles from A to B. That's what this is saying, total miles from A to B. And underneath, I'm saying we're taking miles per hour times hours to get miles. But we can actually do this with lots and lots and lots of different units. Flip the page over. These are just two examples of what you can do. Let's say I have a function that represents the cost per day of something, and I integrate that across a certain number of days. I get the total cost over those few days. Revenue per month. If I integrate that across different months, then I have total revenue that occurred over those different months. So this is actually becomes a very, very real application of integration. For example, number one, water is being pumped into a reservoir at a rate of R of t, and the graph of R of t is shown. I don't have a function, I just have a graph. This graph is the rate. This just means the rate is variable, but the rate is happening. This is an example of a question you may see on an AP exam or something like this. It says, use RAM with n equals 3 to approximate the integral from 0 to 6. The actual integral would be this thing, right? But if I'm using RAM with n equals 3, that's not going to be a very accurate one. Okay, get over that. It's still asking you to do it. RAM means the top right of the rectangle is on the curve. I told you guys we'd be reviewing some of these concepts throughout the semester, so we don't have to hit it all at the end. This is a little review of RAM. Do you remember this? Rectangular approximation method, or the Riemann sums. So these are the rectangles it wants you to draw. What do you think it's going to ask you about the rectangles? Or what do you need to figure out about the rectangles? What do I need to know about each of those three rectangles? Yeah, their area. Let's write their areas underneath. 2 times 20, 2 times 50, and 2 times 80. And if we're going to approximate the area, we're going to add those, 40 plus 100 plus 160. And that's 300. 300 watts. It is 300 gallons. Just gallons. The integral of gallons per minute across 6 minutes is gallons. The integral of gallons per minute across 6 minutes is just the gallons, the total number of gallons that flowed over those 6 minutes. So it says interpret the meaning. We're going to say 300 gallons of agua pumped in the first 6 minutes. Then it gives you R of t is equal to this function. So it's moving you away from the graph and moving you toward the function. How many gallons of water are pumped over the first 6 minute period? What does it want you to do here? It gives you this curve. It wants to know how many gallons of water are pumped. What do you do to figure that out from a curve, from a function? Integral 0 to 6 of negative t cubed plus 12.5 t squared minus 31t plus 40 dt. This would probably be a calculator question. Yes, God. Why does it give you what? It tells you that because n equals 3 means 3 rectangles. If it was n equals 4, we'd have to do partial ones. N equals 6 would be 6 rectangles. But back to this. There are two things that I have to verify here, because if I'm truly going to say this is the number of gallons pumped, I probably need to be sure that my integral that this curve is entirely above the x-axis. Now, this curve matches the curve right above here, so it is entirely above the x-axis. But I want to also emphasize that if you had a problem like this on an actual AP exam, more likely than not, this would be a calculator problem. And you would go directly from here to 258 gallons. Have you had practice typing in an integral into your calculator? If not, get that practice. It's good to know where that is, all the little nuances you have to do to make sure that you get it right. But that's about 258 gallons. We're going to move on because we're going to assume you guys have calculators and can type these things in now. Okay, company estimates that its sales grow continuously at a rate given by this, where S of T is measured in dollars per day. So S is dollars per day, and it wants the total amount of sales in the first 5 days. What do? Is this feeling a little bit easier? The integral from 0 to 5 of S of T dt. Now, I am going to take a second, pause the video, and open up the calculator. Your guys' most efficient means of doing this is actually to go back to the menu and put a graph in. And a graph, so f1 of x is equal to negative 100 x to the third plus 900x squared minus 600x plus 1,000. And I don't really care that the graph is centered or looks good. What I'm going to do is then within the same document, go back home, add a calculator to the document, and now call up my integral function, which is right here. I'm going to do an integral from 0 to 5. And instead of typing the whole thing over again, I'm going to go to the variable key above the 9, where f of 1 is now something that's stored in this document. f1 of x dx. Do you see the value in that? You can actually now change, anything you want later on. So that's 19375. So I'm going to go back and just write that down, 19375. I need to have a unit on it, so dollars. Now it wants the dollar amount of total sales in days 2 through 5. So this is going to be the integral from 2 to 5 of S of T dt. Which part? Where I find the integral, it's right here in this little menu key there. Okay. And you can see the little integral template down here. I'm going to do it again for this next one. Usually what I would do is I'd go up, up, and call this one back up, and then just replace the 0 with a 2. That's going to be quicker. Also, it really, really, really does not like the stylus, so it constantly wants to delete things. See, it's like deleting. It's annoying. Okay, let's try this again. Call this back up. I have no idea why it does that, and it drives all of us in the math department nuts because this does not like it. And if TI ever got off their butts and released a computer touch-friendly version of this, would be nice. Okay, 16575. So 16575. Then here's a tricky question. On what day will total sales exceed 30,000? So what am I really wanting to know here? If it says on what day will total sales exceed this, what do I really need to know? What am I trying to figure out? Integral of? 0 to x. Exactly. 0 to x of the function. And we're going to set that equal to your calculator will actually be able to do this. Watch. I'm going to go back into the graph, And I'm going to create a new graph, so I don't want to mess this one up. And I'm going to graph two things. I'm going to graph the left side and the right side of that function. In fact, I'm going to do better than that because I like doing zeros. So this should be 30,000. What I'm going to graph is y equals the integral from 0 to x of s of t dt minus 30,000. Because then I'll figure out where that graph crosses the x-axis. And when that graph crosses the x-axis, the two of them are equal to each other. Yes, Alex?
You might have already done this, but are you recording still?
Yes. Yes, okay. Thank you. Okay, back to this. I'm going to type in this entire function. This is going to be tricky to type in, but you can do it. So the integral from 0 to x of the function that we already did, so I don't need to type it in again. I'm just going to press the variable key and call it back up. But I need to use a different variable here because I have x as my input. It's not the variable that I'm integrating about. So I'm going to do f of t dt minus, let's put the minus out here, there. And actually see it cross the x-axis. Now, I can bring the y up to much, much, much greater heights, see what I did there, if I want to, and try to start to see where that's happening and what's going on. But it's asking on what day will it exceed 30,000. That would be right here. So I'm going to go Menu, Analyze Graph, 0, and find the 0 of the function. And it's about 6.29. So that would be on day 6. Oh, so that'd be day 7, you're right, because 6 is the end of the 6th day. So this is, say x is about 6.29, so we'll say on day 7. Yeah. It's going to take your calculator a little bit of time to graph it, much more than the computer, because it's using the calculator's processor to do it, but it will do it. Okay, let's get down to kind of an easier example. Number 4, find the total number of words typists typed in the 5-minute period. How would you find that? Integral 0 to 5. The key there is total, and it gives you a rate in words per minute. So 0 to 5 minutes of negative 6t squared plus 12t plus 90. There's some clues that this problem may be one that they could give you to integrate by hand, and one of the big ones is that it looks like it's a clean integral. There's not like decimals and fractions in there. So let's just do this one by hand. This is negative 2t cubed plus 6t squared plus 90t evaluated from 0 to 5. So this really just becomes about plugging 5 in. Negative 2, 5 cubed is 125 plus 6 times t squared, 6 times 25, plus 90 times 5 is 450, or negative 250 plus 150 plus 450. Negative 250 plus 150 is negative 100. So this would be negative 100, 350. Oh, positive 350 words. You can't really type a negative number of words. That'd be weird. I should put words. And I should probably put this underneath because this is like weird. There we go. Oh, no, I don't want to put that underneath because that goes to this. Did the typist type more words in the first minute or the last minute? Yeah. What are the two integrals we're looking at? 0 to 1 versus integral from 4 to 5. So we'll kind of skip over this and let the viewer do this if you want to. The integral from... Well, actually, can we be a little... No, let's not be clear. But what?
These problems, can we just skip that one step?
You mean like right here?
Yeah.
Yeah. Oh, heck, let's do this. So the integral from 0 to 1 would be negative 2 times 1 plus 6 times 1 plus 90. So that'd be 94 words. And the integral from 4 to 5 is isn't that the same thing as the integral from 0 to 5 minus the integral from 0 to 4? Would that make sense? The total number of words from 0 to 5 minus the total number of words from 0 to 4. And we've already figured out 0 to 5, that's 350, minus the integral from 0 to 4 is just plugging 4 in, so -2 times 4 cubed is 64, plus 6 times 4 squared is 16, plus 360. And don't worry, I'll skip over this and just say this is actually equal to 22 words. It should be 360. I said it right. I wrote it wrong. So 22 words versus 1994 words. Clearly first minute. Question. You guys okay with this right here? This little equation I put there? The total number of words from 4 to 5 should be the same as the total number of words from 0 to 5 minus the total number of words from 0 to 4. And I only did that because we already found the first one. So this just made the integral a lot easier. Okay, finally, we'll rapidly do this one. After exercising for a few minutes, a person has a respiratory cycle for which the air intake is given by this function. Amount of air inhaled in the first 2 minutes. We've been done enough of these for you to know this is the integral from 0 to 2 of 1.75 sine of 0.5 pi t dt. Okay, let's pull the 1.75 out. And let's do a u substitution. U is equal to, I'll write the 1.75 out in a minute. U would be equal to this, right? Pi t over 2. So du would be equal to pi over 2 dt, which means dt would be equal to 2 over pi du. And when you pull that out, you have the 1.75 that you already pulled out. You have the 2 over pi, the integral. Remember, you have to plug 0 in, and you have to plug in 2. What do you get when you plug 2 into that pi? So you get the integral from 0 to pi of the sine of u du. I plugged 2 into here. And then let's pull so the integral of sine is negative cosine. 2 times 1.75 is 3.5, so this becomes negative 3.5 over pi of the cosine of u from 0 to pi, which is negative 3.5 pi times the cosine of pi minus the cosine of 0. Oops, not that, 0. Which is negative 1 minus 1. Negative 2 times 3.5 is 7. Oh, units. Liters. Hang on.